The test. Okay, we'll start with question 0. Don't know why I started things with 0, but nonetheless I did. So for what it's worth, here's the first question: is sketch the curves, show intercepts and asymptotes if applicable. So if x equals cosine of t and y equals sine of 2t. So the parametric equations, or we're looking at them as parametric equations. Okay, I asked you to graph these three things and I didn't say how. So a lot of you use something like Desmos. And okay, fair enough. It's not what I had in mind, but I didn't specify how to make the graphs. The other plan would be, the other initial plan would be to make a table of values. I sure don't want to do that. And after all, let's face it, that's exactly what graphing software is doing. So let me try graphing it sort of, I want to say with a more mathematical elegance. And what would that be? Let's solve this one for t and substitute it in there. And we'll get a function in regular rectangular coordinates. And maybe we'll say, like hint, hint, right? But maybe we'll say, oh, yeah, I know what that is. And we'll be able to graph it like that. So from this, we get t is equal to cosine inverse of x. We'll substitute it in there. So that might be hidden in the glare there. But t, the letter t, is equal to cosine inverse of x. We'll substitute in there, and we'll get y is equal to sine of 2 times cosine inverse of x, which looks pretty horrible. I would like somehow to sine and cosine to wipe each other out. They don't, but if I could turn that into cosine, maybe there's hope. So let's use our favorite Pythagorean identity that I've talked about several times now in class. And we'll write this as, and I told you it would come up a lot, and it does come up a lot. So it's absolutely worth knowing how to rewrite sine in terms of cosine. And it's equal to 1 minus cosine squared of what you have there, 2 cosine inverse of x. And you rejoice, except you don't rejoice. And why don't you rejoice? Because it's pesky 2 right here. So yuck, we're going to use a trig identity. I don't know why I say yuck. I don't know why. I just used a trig identity, and I used it gleefully. And now I'm using a trig identity, and I'm not so gleeful about it. It's probably just because I don't use it as often. That's probably how I have that emotional response to it. So this is custom setup. Hey, remember, maybe we should write it like this, because after all, that's what it means. So just focus on what's in the brackets there. You have cosine is a double angle. So we can use a double angle formula. And there's a couple different versions of it, but the version we'll use, I'm leaving all this alone. It's all the same. That's the same. None of that's changing. Brackets, none of that's changing. But so I'm doing something I shouldn't do. I'm looking ahead. As I recall, and I can double check this, but cosine of twice an angle is equal to 2 times cosine squared of the angle minus 1. Pretty sure. Yeah, I'm sure enough. I'm not going to bother looking at it, but you can go just look up Google trig identities and make sure that's right. So instead of cosine of the, you know what? I better double check this. Hold on one second. I don't want to continue on and do all this stuff only to have used, okay, only to have used the identity, to written down the identity wrong. So what do we have here? Instead of cosine of twice an angle, we have 2 times cosine squared of the angle. Oh, I wrote like that, like theta. So this here, I don't know how to. Well, here I'll underline it. That's theta, and that identity right there. So it's 2 times cosine of that business, cosine inverse of x, and then minus 1, and all that squared. Something about this I'm not liking, but I'm going to keep going here anyways. I don't know what it is. I'll let you know. I don't know. Something, I feel like something's not right, but we'll see. So square root of 1 minus brackets. Let me make sure 1 minus, okay, that looks good. 2, these cosines cancel each other out, and you wind up with x squared. So 2 times x squared minus 1. and all that squared. That's the part that's bugging me. Bugging me a lot, actually. Bugging me to the point where I'm really starting to suspect that I've made a silly mistake here. But let me continue on. And then if I have, well, you'll never see this because I'll just make a new video. But, what do we want to do with this? That's not readily graphable. Let's square both sides. And if I square both sides of this, we'll get y squared equals 1 minus 2x squared minus 1 all squared. Now, if this square hadn't been here, this would sort of more or less obviously be the equation of an ellipse. Boy, I'm really tempted to do something off camera right now, and that's to throw that into Desmos and see where we're headed here. But hey, let's multiply this out. Yuck. Equals 1 minus, and what would we have? 4x to the fourth minus 4x squared plus 1. And then go one step further. Look, we'll have 1 minus 1. They'll be gone. I guess that's kind of a good thing. And what am I going to have left here? We're going to have 4x squared minus 4x to the fourth. Tell you what, let's factor a 4 out. As a matter of fact, let's factor a 4x squared out. And then what do we have left? 1 minus x squared, like that. Let's square root both sides, and we'll get y equals 2x times 1 minus x squared. And if I multiply this out, we get y equals 2x. When I square root of both sides, we should probably stop a little bit longer and think about whether that's justified or not. Because remember, if something were to be negative and I took a square root, well, you're not supposed to do that. And could that happen? Yeah, I see it could happen here. If x squared is bigger than, for example, 1, then x squared will be a number larger than 1. When I take 1 and subtract that, that'll be negative. But nonetheless, we can maybe go back and remedy that. Minus 2x cubed. And perhaps a more normal way of writing this would look like this. And that's a cubic, and you've certainly graphed many, 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 many cubics. But I don't think that the graph of this looks like a cubic. But maybe it does. If we were to make a quick graph of this cubic right here, we can tell. I mean, generally it's going to have that sort of a shape. We know that just from having made so many graphs. It's because that -2 out front. It's going to go through the origin. It's a little less obvious where the dips and humps are going to be. We could do a little calculus on this right here. Do the first derivative test, second derivative test. Again, it's a little different. It might look something like this. That sure is not anything that you get from this. Now my question is should I stop and make a new video, or should I try to figure out if and where I went wrong? I don't know that I went wrong. I definitely don't know that for sure. How many minutes? 8 minutes into this. Let's see if it would be useful. It might be useful to take a quick look and see. From here, I solve for t cosine inverse. That's right. Put cosine inverse there. We got this. I use the standard Pythagorean identity to go from here to here, to write sine in terms of cosine. Sine is equal to the square root of 1 minus cosine squared, and I wrote it like this to get out of the way, so that's correct. I used that identity up there, and I did go online just a second ago and checked it. Check that out. Let me double check that. Just to triple check that. Cosine of twice an angle. You can write it a couple of different ways, but 2 times cosine of the angle squared, and then minus 1. So that part is right. Let's see, where are we here? We get this. That's good. Those two cancel each other out, and you get 2x squared. That's right. Minus 1. That's right. Hey, I'm going to stop this video. I'm saying that out loud.